Welcome back to the workshop. We want to take a look at our last connective in the first section of the appendix, which is the biconditional. Now, biconditional, of course, we're looking at two conditional statements being combined together into one larger statement. So we're considering two component statements, P and Q, and then what we're doing is we're considering the conditional P implies Q and the conditional Q implies P. And for the biconditional, we're looking at when both of those conditionals are true. So in the next section, we'll take a further look at conditional, or actually truth tables. We'll take a look at the biconditional and observe that it is the disjunction of the two implications or the two conditionals. So we'll take a look at this a little bit more later, but for now, what we want for the biconditional is to recognize that the biconditional is true when both of the conditionals are true. So let's take a look at that. All right, so again, the truth table we'll take a look at later in our next section. But for this section, we want to consider a couple of biconditionals and determine if they themselves are true or false. So still we want to work with is the component statements true or false. Of course, this is still false. 5 plus 3 is not 15. April 24th, 2020 is, or was a Friday, rather. Some cows are, in fact, brown. However, chocolate milk does not come from brown cows. All right, so we want to look at the biconditional. So P if and only if Q. All right. So P is 5 plus 3 is equal to 15 if and only if. Now that can be abbreviated to IFF. I'm not sure why exactly it's that, but that's what it is. So if and only if can be abbreviated by IFF. All right, so 5 plus 3 is 15 if and only if. April 24th is a Friday. Of course, April 24th, 2020. Excellent. So what do we have in this case? Well, if we were to look at the two directions, P implies Q, P is false, so we know P implies Q is true. But what about Q implies P? Well, April 24th, 2020 is a Friday, but 5 plus 3 is not equal to 15. So P implies Q is false. So there's a couple different ways that we could write this out. Probably the easiest way is to say that since P implies Q, I'm sorry, Q implies P. That's the one I'm looking at here, right? The second statement, if the second statement, then the first one, if April 24th, 2020 is a Friday, then 5 plus 3 is equal to 15. That particular statement is false. So since Q implies P is false, the biconditional is false. All right. For our next one, R if and only if P. So some cows are brown if and only if, let's see, 5 plus 3 is equal to 15. Now, in this case, the forward implication is actually false because some cows are brown, yes, but still 5 plus 3 is not 15. So we have true, false. So that's going to give us, since the individual implication is false, we're going to get that the biconditional is false. So since let's see here, P implies R is false. Oh, I'm sorry, no, it was the forward one there, since R implies P. Since R implies P is false, the biconditional is false. All right. There's a different way that we could have written each of these, and maybe we want to do that. It's nice if we want to leave it in the same order, so P and Q, in this case, P implies, I'm sorry, we want to say that the reverse direction was the one that gave the problems, okay? So we wanted to talk about Q implies P, and so we could write it this way if we wanted to, that would be fine. And this, it was already in that order, so that's good as well. So since the reverse direction, I call it typically the forward direction, P implies Q, and the reverse direction, Q implies P, because we have the two directions, forward and backward, forward and reverse. We need to check both of those conditional statements. So the backward or the reverse conditional is false here. Q implies P. Okay. And in this case, R implies P is false, giving the biconditional is false. All right, so R if and only if Q. All right, so some cows are brown. If and only if Q is April 24th, 2020. Is a Friday. Of course, both of these statements are true. So the forward direction, true imply true, you're good there. The backward direction, true imply true, you're good there. So in this case, since both, we could call it R implies Q and R implied by Q, maybe you want to say it. So since the forward and reverse directions are true, the biconditional is true. All right, and then finally, S is chocolate milk. Comes from cows, brown cows. If and only if 5 plus 3 is equal to 15. Now, in this case, both of them are false. So both the forward direction and the reverse direction are going to be true. So chocolate milk, if chocolate milk comes from brown cows, then 5 plus 3 is equal to 15. True. If 5 plus 3 is equal to 15, then chocolate milk comes from brown cows. True. Because in each case, the premise was false. All right. So in this case, still, since both directions are true, since S implies P and S is implied by P, or P implies S, are both true, the biconditional is true. And that's it. All right, so again, we'll take a further look at biconditionals in the next section, and we'll do that by taking a look at constructing the truth table for it, rather than just kind of saying what it is, which we've been able to do for the previous examples. So I'll see you guys back in the workshop for one more video on statements and connectives, where we revisit conditional statements and take a look at some variations. But I'll see you guys back in the workshop very soon.